Hi folks, welcome back to Physics with Captain Rod. I'm making this video here to help you out with number 24 in chapter 14 here in your OER text. So let's see, what does it say here? A 0.05 ice cube at negative 30 degrees centigrade. So, I got this ice cube at an initial temperature. So let's see, let's call this T1 ice of negative 30 C. It's placed into 0.4 kilograms of water in a well-insulated container. So, all right, let's draw a picture here. We have our container. And it's very important to note that this is an insulator. And that means that it's not going to absorb any energy. This container is got some water in it. The T1 for the water, 35 degrees C. All right, so when the ice gets plopped into the water, bloop. All right, we're going to have a heat transfer now from the water to the ice. Now, there's a couple things to consider here. One thing that you have to kind of get figured out is whether or not all of the ice is going to melt. The amount of heat it takes to melt the ice, whoops, put a QM here, that's going to be the mass of the ice. Ooh, I got to back up. So that ice is at negative 30 degrees. So in order to melt it, first it's got to come up to temperature. So I would calculate that first. That's going to be mass of the ice, specific heat of ice, times a delta T, and that is 30 degrees. Then compute the amount of heat the water is going to give up going from 35 to 0. And that's going to be mass of the water, specific heat of water, times a delta T, and that delta T there is going to be negative 35. And compare these two numbers. Now, my guess is this number in magnitude is going to be quite a bit better, quite a bit more than this, meaning that for sure there's going to be enough energy to bring the ice up to its melting temperature. All right, now we're going to calculate the amount of heat it takes to melt the ice. Put a little melt here. So that's going to be mass of the ice times the latent heat of fusion for ice. Now, if the sum of these two numbers is bigger than this, it means that, whoops, actually let me back up. If this thing is bigger than the sum of these two, it means that the ice is in fact going to melt, and I'm pretty sure that's probably going to be the case. So now we can write an equation here for that. When it's all said and done, we're going to have the heat term for the water plus the heat term for the ice should add to 0. This will just have one term. It will be an MC delta T, which you can write T final minus T initial. This thing right here will probably end up with 3 terms. You're going to have an mass of the ice, specific heat of ice, times a delta T. This is the heat term required to get it up to 0. That delta T is going to be plus 30. In addition to that, you have to melt the ice, so you're going to have a mass of the ice times the latent heat of fusion. And in addition to that, the water's temperature is going to come up some. So now, when I say water, the liquid ice, so you're going to have a mass of the ice times specific heat of water. I'm sorry, I'm running out of room here. And then the delta T can be written T final minus 0. And that's all going to equal 0 there. So you're going to have one long equation. It's basically going to be this for the water plus this, and it'll have 3 terms for the ice equals 0, and you'll solve for delta T. So hopefully that's enough to get you get that thing worked out. If not, drop me a line, and I'll help you out with it some more. All right, have a great day.